I hope you guys can see my screen.
Yes, we can.
Right. So today we are going to talk about the architectural patterns, and in this session we will cover different architectural patterns which are mainly applicable to ODC framework here. There are architecture patterns which were available in O11 as well, but these ones are specifically for ODC because we are going to talk more about library and applications here. So first topic would be library reusability patterns. Second would be integration patterns. Third would be sharing data patterns, and then distributed transactions. Yeah. ODC mentor we are not covering in this session, so please ignore that. So library reusability patterns. Now, as we all know, libraries are kind of uh, the unit of our ecosystem on ODC, where they mainly contain the business agnostic elements. So libraries are stateless. We all know libraries they cannot have entities. That's why. And then libraries are supposed to be reused across different applications. I mean, it's not a mandate, but in most of the scenario, we end up having that situation where most of the reusable elements they are bundled into a library, and then those libraries are used across multiple applications. Yeah. So as we all know, libraries are a core building block of ODC. They serve as repositories for reusable UI and logic elements. So reusable UI means it could be any patterns, like let's say some blocks, reusable blocks, or menus, yeah, and it could be themes, and then certain logic elements as well, like certain if there are certain reusable functions or utilities, those as well can belong to libraries. Yeah, and third one, obviously, these are the elements which can be shared and reused in multiple applications. Um, so, if we talk about one of the use cases of the libraries, how they are reused across applications. So, one is the sharing of look and feel. So, we all know that in our systems, all the applications they follow certain theme, right? And it's not only applicable to our systems, but any application in any programming language that we build, it has to have a certain look and feel, predefined look and feel, which is followed as a standard across the application, right? So there could be a blue top ribbon, a top menu, yeah, and some copyright statement at the bottom, and so on. So these are all part of theme, and these standards then you would see being followed across the application. So how we achieve those in our systems? They are achieved through the themes. So themes provide allow us to tailor our applications look and feel as per our need or the business needs, right? So in this diagram, you can see there are two applications. One is a directory application, and another is a vacations application. And theme is a library. Yeah. So both directory and vacation applications are taking a reference from the same theme. So they both would have the same look and feel. They can apply their own certain customizations within the application itself, but then more or less they will be it will be a common look and feel because they are using the same theme. Um, so if we start then with the if we expand our scenario, so now let's say we have a same directory application, yeah, and then it has two versions. There is a mobile version and then there is a web version. Now mobile and web, again we want them to use same color combination, same certain logos and so on, right? So in that case, what we would do is that still the CSS would be common for both the applications, right? So they would have a common base theme. So it would have the very mini bare minimum common elements which are applicable to both mobile as well as the web application, right? And then we will create another layer on top of the base theme, which will be the mobile theme for mobile application and a web theme for a web application. And now our mobile application will take a reference of mobile theme, and it will take the web application will take a reference of web theme. So this way we have introduced the inheritance in the theme, right? So there is a base theme which is being inherited by the mobile theme and web theme. Mobile theme then applies its own specific styling for mobile application, and then the web theme applies its own web specific styling, right? And then these would be used respectively in mobile and web applications. So this is how we are. So I mean, in all these in this scenario, what is happening? We can see that the library are being reused, right? So base theme again is a library, mobile theme is a library, and web theme again is a library. Yeah. Um, and then obviously when we build any theme in OutSystems, there is the OutSystems UI library which is common, and which is kind of reusable. I mean, it's kind of a package which contains all the support for different styling, different elements, and different UI patterns that are available in our systems. So this is the one which we use as a base, and then on top of it we apply our own business specific styling. Now, the next, yeah. So I already explained. They inherit. So there is a base theme which inherits, which is being inherited by mobile and web theme, and where mobile theme and web theme are applying their own stylings needed for mobile and web application respectively. Now sharing the blocks across applications. Now, so far we talked about look and feel. So color combination, some kind of CSS, yeah, some kind of styling and so on. So that we talked about so far. Now comes the UI elements. So UI elements usually they are wrapped within blocks, right? So blocks are they are actually intended to be reused in more than one places. So the same thing we are doing here. We are having reusable blocks placed in our library, which is called patterns here. So in this patterns library, we have kept the reusable blocks which different applications would need. So one of them is header, obviously. Yeah? So header. So most of the applications they need header in their screens. So header is one of the reusable block which we are using here for both directory as well as vacations application. Yeah. So now directory, now here, although the block is part of, so I mean again we are talking about different possible use cases. Yeah? So there might be so many others, but we are talking about some very common use cases here. You can come up with your own. Is just to give some guidelines on how to reuse the libraries for different purposes. So directory and vacation, they both are using the header block here. But vacations, the directory application has the information about the header. So I have a header, but I don't know what to fill in that header, right? So what will happen? The patterns, the block which is contained in the patterns library is just as the placeholders for different elements in the header. The actual information is not there. Yeah. Here the directory application is the one which has the information about the headers. So what happens directory application when it needs the headers in the application, it can obviously pull it up from its own database. Whereas for vacations, when it wants to reuse the header block in itself, it still needs the header information. Now to get the header information, it will reach out to the directory application and get that information. Now, since we know that applications in ODC they cannot interact with each other through server actions, so here we have to use a service action. So directory application is exposing a service action called get header info, and the vacation application is calling that service action to pull the header information, and then it will link or bind that information with the header block, which it is getting from the patterns library. Yeah. Then comes the another use case where we want to have a app switcher menu. So there is a common menu where so it is more like a orchestration application, right? So we have different applications like vacation directory travel portal. So there would be a common orchestration layer, or a screen where the user would land as soon as the user logs in, and then he would see different options like for different applications to navigate to, and he can select any one of these options and then can navigate to the respective applications, right? So this is also another use case, and how we implement that. So again, here we have three applications: directory, vacations, and travel portal. All three of them are using the library. They all are dependent on a library called menu. Menu gives them app switcher menu, which we just saw in the previous slide. And this menu would then, so what we can do here, we can simply have external links to all the three applications in the menu, and that won't create a dependency between the library and the respective applications. And then by clicking the menu, then whenever the user clicks on that menu, he would be redirected to the respective application, yeah? So this is how the app switcher menu is being implemented in this situation. uh, then coming to the integration patterns. So obviously we know, like, we need certain integrations with external systems. So there are integrations within our OutSystems applications, and then there could be integrations with external systems. So here we are mainly going to talk about the external systems and how these integrations work. Um, so integration service wrappers is one of the cases here for how we use libraries. So integration service wrappers, they are mainly for promoting the reusability across applications and reduce third-party change impacts. So what happens when we integrate with any third-party system? Um, Now the third-party system is not in our control, right? So they have their own development team, they have their own business sponsors. So they might change certain functionality, they might change certain features, and as a result of those changes, some of the elements that we are consuming from those third party applications or systems might change or might get impacted. Now, when that change happens, if we are directly dependent on the third party system, then we are also going to be impacted. So, if let's say there was a parameter that we were using from third party system in an API or something, and that parameter is no longer available now. So, and if we are still using that parameter in our application, then our application will either not get that information, or our integration will be broken, right? So there might be various failure scenarios possible. So in order to reduce those kind of impacts on our system, because of any changes that happen on the third party or the external systems, we usually introduce wrappers in between. So wrappers actually act as cushion between our application and third party systems. So if there is any kind of changes on the third party system, then wrappers would kind of absorb those um, changes and ensure that our system is not broken because of those changes. So there could be various kind of integrations possible. Now, one is called direct integration. and this is also called as a black box approach. Yeah, so we again have the directory application, vacation applications, and they are dependent on an ERP system. Yeah, and we are using consuming a REST API from that system. And now we did not want to connect directory application and vacation application directly to the ERP system through the REST API, because obviously we wanted to introduce a wrapper in between. And now here for that wrapper we are using a library, so which is the ERP connector here, right? So what is happening? The ERP connector is consuming the API from the ERP system. It performs any processing if needed on the information that we get from the ERP system, and then returns it to the caller, which could be a directory application or the vacations application. Yeah. So here we are kind of abstracting how the integration is working from the directory and the vacations application, and that's why they also call it a black box approach. So all these application need to do is through a server action or some other way of communication, they need to request something from ERP connector, and then the ERP connector would take care of how to communicate with the ERP system, get the information, process it, and return it back to the directory or the vacations application. Yeah. And because this communication is happening in real time, this is called synchronous communication as well. So directory application, whenever it needs the information from ERP system, it immediately invokes the server action, let's say in this case, from the ERP connector library. The ERP connector library would immediately then reach out to the ERP system through the REST API, get the response from the REST API, and return it to the directory application. So the integration is working in real time. The directory application does not have to wait for getting the response, or does not have to queue up the request anywhere, right? So this is why the direct integration involves synchronous communication. Now, like I mentioned, so the communication is happening between directory application and or vacation application to ERP connector library, right? So the communication is happening through a server action. So obviously, when we have a server action connecting any two applications, any two libraries, or any two application and library, the dependency created through a server action is called a strong dependency, right? Um, the next integration possible could be with cold cache. So what we do, in case of cache, as we all know, right? So we cache the information until it becomes irrelevant. So let's say I request, I have certain requirement based on certain criteria, and I request that information and pass on the criteria to the third party system, and I get and I get the response back. Now, until I change my criteria, my response is still good, right? So I don't need to fetch the fresh information all the time. So that's when there's the concept called cache. So we cache the response that we got from the external system, and as long as my request criteria is same, or the cache has expired, I don't need to reach out to the external system again to fetch the same information. So that way, what happens? My processing improves, my performance improves in my application, because I'm not reaching out to the system, fetching the information from the database or wherever, processing it and getting it back and showing it to the end users. Yeah, so the processing time is saved when I'm using the cache. So here and now we see that there is a directory application, which is connected to a ERP connector through a server action, and then ERP connector is connected to a ERP API. Now there is a timer, which is so in the entities in the consumer. So there are entities again like this. So let's say this employee is one of the entity in directory application, and there is a timer which is running to sync the information from the third party system. So what happens? This timer would run. It will get the data at regular intervals from the ERP system through ERP connector, and then it will hold that information into the employee entity. So that's how the we are regularly getting. So this is um, although we are getting the information from the ERP system, but we are not getting it in real time. So what's happening? We are there is at certain regular intervals we are fetching the information from ERP connector regarding the employees, and we are storing it in our entity. And whenever directory information needs the employee detail, it won't go to ERP system right now. It will simply request it from the employee entity. So we are in a way kind of caching the information in advance that we might need for our any future requests, right? So obviously, like I mentioned before, this kind of a cache, what it does, it improves the performance, it improves the scalability. Use cases need to cope with some delay on data updates. So now let's say, obviously, because we are caching the information, right? We are storing the information in the employee entity, and we are fetching it or refreshing that information at certain regular intervals. Now, if there is any change that happens on the ERP system on about for any employee during that interval, so I won't have that updated information in my employee entity, right? So that is why the system should be resistant or immune to any such kind of changes that are happening in the third party system, which means that our systems uh, should have this kind of expectation that I won't be getting a real time information. There are chances that if I fetch it now, information might be outdated in the employee entity compared to if I fetch it after 5 minutes or after 10 minutes. Yeah. So latest information would be available only when the next sync happens. Synchronization logic can be now again the synchronization logic can be optimized. So there could be various ways to do it, and I mean like this is not the session for discussing those strategies. But yeah, there are various built-in actions and approaches we can use to improve the synchronization logic. Now, the other approach could be integration with cold cache and real-time sync. So we are now improving it, right? So uh, we are using the cold cache. Yeah, we are caching the information in the employee entity like we were doing in the previous scenario. There is a timer, sync employee timer, which is running at regular intervals. It is fetching the information from ERP system and storing or updating the details in the employee entity. Now, like in the previous scenario, there was a downside that if any update is happening in the data on ERP system between any two sync intervals, then the employee entity won't have the updated data until the next sync happens, right? So to overcome that situation now, in this integration strategy, what is happening? Whenever an update is happening in the ERP system, we have exposed an API from directory application so that the ERP system can inform us about that update. Yeah. So we are so now. I mean, obviously, the ERP system is going to not send me all the data. It will send me just the information about the update that has happened in the ERP system on any employee record. So what it will do, it will simply update me, okay, that there is a update in my system, and this is the information. Yeah. So there could be two situations. One, that ERP system sends me the updates which it has about the employees through this REST API call. That could be one situation, or it could simply inform me that, okay, I have an update. Please trigger your synchronization logic. So it can just tell me that, okay, there is an update, and then what the directory application will do, it will immediately wake the timer to perform the sync again. So that way, what will happen? I will have the updates available in my employee entity in the real time, right? So in this situation, what we did, we introduced the callback endpoint, a REST endpoint. There is the external system is triggering the synchronization. So what the ERP system is doing, it is just informing the directory application that, okay, I have an update. Please sync the information from your side. And so what it does, it eliminates the situation which requires us to poll the information. So the polling concept, right? So constantly we have to, I mean, if we really want to get the real-time information from any system where we are not requesting through a REST API, then we keep checking with the external system that, okay, do you have an update? Do you have an update? Do you have an update? So that kind of a check, a frequent check that we keep performing on the external system for the updates, is called polling. So in this scenario, we don't have a need for polling, right? Then comes the transparency service pattern. So now this one is kind of very common, where we are integrating with different external systems. So here we can see again we have directory application, directory locations application. There is a library sitting in between, which is notification, and then there is another layer of libraries, each one for each system, one for each external system, right? So there is one for Slack, there is one for Teams, there is one for email, and then each one of those libraries is connecting to the external system through the REST API, right? So now, see, I mean, more layers we add, more abstraction we introduce, right? So this abstraction. So what we are doing, all the applications just have to go out and request notification library. They don't have to. So I mean, my directory application does not have to need to know about the Slack library. It does not need to know about Teams or emails library. Now in future, let's say I introduce one more external system, maybe Skype or Zoom, and then I develop the integration for that. I don't have to change the directory application to connect to those new integrations. Directory application just needs to know which system it wants to communicate with. It needs to inform the notification library, and then notification library will take care of it. Yeah. So this way, we have we introduce more abstraction for the end use, the applications which are the consumers of those third party integrations. So we abstract several. So here we are obviously abstracting several implementation into a single service. So like Slack, Teams, email, everything is abstracted into notification service. So directory application, vacation application, they just know about notification application, and then it makes it easier to add more implementation. Like I explained, I can have integration introduced for Skype, Zoom, or whatever, and there is a room for that. And my directory and vacation application don't need to worry about any of the changes on their side. So they will have less impact in terms of consumer, in terms of like, okay, so let's say I created static entity which gives me all the options to connect with different external systems. So when I communicate with the notification library, I will have to inform it, okay, I want to connect with Slack, Teams, email. Now if I introduce another system, then the static entity will have to be updated, and the directory application then needs to just specify that option, that, okay, I want to connect with Zoom now. So those are that is the minimal impact which will happen on directory or vacations application. Uh, Now there is another thing we are saying transparency microservices pattern. So it is the same thing as we had in the previous picture, previous slide. So again, the same directory application, the vacation applications, and then the same integration with Slack, Teams, and emails. But then the change we see here is that the notification application, the notification layer, has been changed from a library to an application. Now, why the change is needed? It's because we wanted to store certain information about the communication which is happening between the directory or vacation applications and all those third party integrations. So we wanted to maintain a kind of a audit log or a communication history here. And as we all know that libraries are stateless in nature, they cannot have entities. So to handle that situation, we have replaced the notification library with a notification application. Yeah. Now, so far we talked about the library pattern, integration pattern, and then the next pattern is the sharing data patterns. So now the data patterns, now the sharing of data, there could be two patterns possible, right? One could be the reference data and one could be the business data. So reference data could be just like I mentioned, like some kind of uh, static information which is not dependent on business, some kind of helper information. Yeah, so some very basic or generic information which is business agnostic. So like let's say I want to know about the list of all the countries. So countries are same, right? Regardless of what business I use, what application, what business application I'm using. So list of countries would still remain same. So that kind of data can be called as reference data. And then another could be the business data. So when we say business data, so there could be like a finance application and it wants to consume some data from another application which is related to employees. So that employee information now is the business data. Yeah. So this is how we can distinguish the reference data from the business data. Now, sharing of reference data. So again, we have the three applications: directory, vacations, and travel. And they want to consume certain reference data from another application, which is location reference data application here, and in which it has two entities, right? City and country. So now, if directory application or vacation application or travel portal application, they want to pull this information from location application, it can simply take a reference of those entities, right? So what we will do in this situation, we will make those entities public, the country and city entities, and directory vacations or portal application can take a reference of those entities and pull whatever information they want from them, right? So yeah, the same thing. So the entities can be made public and they can be referenced by the consumer applications, and entities can be used directly in the applications, which obviously requires less development effort, because when you directly um, have a reference to an entity, it's easy to write the aggregate or a SQL if needed to pull the information from the entity, right? You have access to then all sort of built-in features which are available with aggregates or SQL, right? As compared to there is a service section sitting in between and it gives you only specific, it gives you data in only a specific format, yeah. So you don't have those kind of restrictions if you have direct access to an entity. So this is how we are sharing the reference data between applications with the consumer applications from a reference application. Now, next comes the sharing of business data. So, now there is a directory application, a vacation application, travel portal application, and they want to consume some information from the billing application, right? Now, here the important point to note are that, sorry, important points to note here are that we have the stable data model. Although billing data is business data, but it's kind of a stable information. So we know, like let's say frequency of billing. So we know the billing frequency is monthly. Now that is not likely to change in years, right? So I mean, most of the applications that, or most of the services that we use today, they have the billing running every month, right? So the billing frequency won't change. So if we have that kind of information stored in the billing application, which is stable, and it does not change very often, so that information can again directly be consumed by the consumer application through public entities. So this back to the same information. So there is a um, again the same three applications, and they are consuming the billing and the billing information from the billing application. So and one of the entity is the supplier entity. So supplier information, it's going to supplier information. I mean, I can have more suppliers added to it, but then I don't. It's a plain supplier information, right? So it does not change. It has same attributes, which usually remain same. They don't change very often. And while pulling the supplier information, I don't want to. I don't require to apply any kind of business rules or constraints or pre-processing on that supplier data, right? I can directly consume that information in my directory vacations and travel portal. So, and obviously, supplier information, it would have certain attributes which are not very complicated. So I don't need very specific business knowledge about building application either. So in those cases, it is perfectly fine to consume the entity directly, like we were doing in the previous scenario, right? In case of reference data. So in this case as well, I can use the public entity directly in my consumer applications. Now sharing business data with business rules. So now there is some billing application. It is sharing some data with the consumer applications, but it has some business rules defined on top of it, right? And so in this application we can see there are entities in like invoice letter, invoice items, invoice payments. So usually invoicing is complicated, and you have to have good understanding of how invoice works, invoice business, and yeah, you cannot, and it might require some pre-processing as well before we consume it. So here, if I simply allow, so there could be two ways to consume this information, right? One is that I simply make those entities public, and the consumers can use that information. But what about the business? So they need to know the business on about how to consume this information, which parameters means what, yeah, and how different calculations happen using different attributes in those entities. So all that information is needed before we to properly consume the information from these entities. Yeah, and these entities are also kind of likely to change. I might change the invoicing terms. I might change the some attributes in my entity. I might change certain rules on how I process invoicing information. So in those risky, consume the entities directly.
Okay, guys, can you hear me?
Yes, Neha.
Yes, ma'am.
Yes, yes,
Oh,
yes.
okay. I guess there was some problem with Junaid's system because I was not able to hear him properly at the end. Was that with all of you?
Yes, ma'am.
His voice was breaking, right, at the end?
Yeah.
Okay, thank you. Let's just wait. I think he'll join back. So let's just wait for 2 minutes. He'll be here. Okay, I just talked with him. He is joining back in a minute. In the meantime, guys, I'll tell you, please pay attention. We'll have quiz on the basis of the content covered in the session, right? So at the end, once this technical session is over, we'll have quiz, which will help you to get voucher.
Hey, sorry guys, I got disconnected.
It has, yes, no problem.
And thanks Neha for informing me. Otherwise, I would have finished the entire presentation. Okay, let me share the screen again.
Yeah.
So, did did I mean was I connected when I was discussing this slide, Neha?
Are you sharing the screen? I'm not able to see.
Okay, just a second. Yeah, can you see the screen now?
Yes, sharing business data with business friends.
This was the one, right?
Yes, you can explain this.
Yeah. So in this one, what I was talking was that in this scenario, there is a billing application and it contains various entities to store the billing related information like invoice header, invoice items, and invoice payments. Now, what happens when we have this kind of information which is complicated? Um, it is it is not a good idea to share this via public entities. Instead, what we do, we try to abstract that information inside a certain logic, which we want to centralize, right? So we are abstracting the business logic in a service section, And what it through this we are also achieving the centralization of the business rules. So all the business rules are centralized. I don't need to have the directory or vacations or travel portal applications to know about all the business rules applicable to the invoicing concept. In ownership of maintaining those business rules or updating them, yeah, whatever, is also kind of clearly defined. It's the billing application in the team responsible for it which is responsible to maintain the business logic. So the ownership is also very clearly defined about these business logic. So in these cases, yeah, like so it was not recommended to share the public entities as is. Instead, introduced an abstraction layer, which is a service section, and it encapsulates the entire business logic and the processing that is required to uh, fetch the information about invoices properly. And on the consuming application, they just need to know about the service section and the output structure of that service section to consume any information. Uh, yeah. Now sharing data between apps. So this is kind of a summary of what we have discussed so far. So there are two paths: the reference data and the business data. Now, if reference data, obviously it is stable, so it is perfect. So the path is like the final destination is that expose the information through public entities or expose it through service sections, an abstraction layer, right? So reference data, obviously it is perfectly fine to expose it through public entities. With business data, there could be different situations. So one is that the data model is stable. Other could be that yeah, it is stable, so obviously it can be shared via public entities. Other situation could be that the data does not evolve frequently, so again it could be shared publicly through entities. And otherwise, if there are complex rules which change very often and so on, then in those cases it's recommended to use the service actions to encapsulate that business logic. Now, distributed transactions patterns. This is kind of a situation where we have the service actions introduced in between, and there are situations where we have to take care of those transactions. So, distributed transaction usually is that if you remember, if I'm performing a series of database operations within a server action, they are all running in one single transaction, right? Whereas if I'm doing it through different server actions, yeah, or set of service actions, yeah, I mean, if a service action is involved anywhere, or there is a sequence of action which are not synchronized or not part of a single transaction, then it becomes a distributed transaction. And when it is a single transaction, it's easy to manage, because if there is a failure, then the entire set of transactions is rolled back. But if it is distributed transaction, then the rollback does not happen for everything. It just takes care of the transaction which has failed. It does not care about the other transactions which were kind of part of this entire processing. So in those cases, so many failure situation might happen, and those need to be tackled differently based on the business logic that we have implemented, right? So ODC architecture, right? I mean, as we all know, there is it's very much uh, encouraging the loosely coupled concept of applications, which obviously then means then that there are service actions involved, and when then service actions are involved, then the transactions become distributed. Yeah. So although it looks very nice to have loosely coupled applications and then independent life cycle and so on, all the benefits, but at the same time there is an overhead of distributed transactions as well. So like here in the last image, we can see there is an application which is performing certain activities, So first transaction goes to first application, and then the second one goes to second application. And now let's say they are all related. They are, I mean, like all these transactions are needed to achieve one single task, yeah, or one ultimate objective. Then in that case, I need to ensure that all these transactions are kind of orchestrated very well, so that if there is a failure at any point with any of those transactions, then other transactions are taken care appropriately based on the business we are implementing here, right? So now if we look at the one of the use cases, which is the online insurance policy subscription. So here what happens, the first step is, so there are again, yeah, so there is a home insurance application which is kind of orchestrating this subscription functionality. And then there are different applications. Customer portal is one application, claims is another application, and billing is another application. And they all have their own individual responsibilities. Now, if the end user wants to subscribe for a policy, so what it will send a request to home insurance application. Home insurance application will uh, get a will send a request to customer portal to fetch the customer details. The customer details will be returned to the home insurance application. Then the home insurance application is going to call a service section from claims application to subscribe a policy for that customer. Yeah, and if everything goes well, then the claims application will return the policy details to the home insurance application. And then finally, the home insurance application will create a payment transaction for the customer, and then the customer will perform the payment, and then the payment will be taken. This payment part is being taken care by the billing application. Now, if payment goes fine, then the payment confirmation will be returned to the end user, and and then the process will complete. So this is how the mm, entire flow is working, and there are different transactions involved, right? So every time we are calling a service section, it is an independent transaction. Now let's look at, so this is the same explanation that I provided on the previous screen. There is a customer who wants to subscribe for an insurance policy. Home insurance is the orchestration screen or the application. The logic is triggered and orchestrated from there. The customer portal is there to provide the customer details. The claims application is to subscribe the customer for a policy, and then the return the policy details. And then the billing application is to process the payment for the customer and return the confirmation. Yeah. Now, if you look at it in terms of the familiar diagrams, the more technical diagram, then this is how it would look. There is a home insurance portal sitting on top. There is customer portal, which is the first one here, which is certain entities to store the customer related information, and service section to return that information. Similarly, the claims application has certain entities to store the claims information and the policy information, and the service section to interact with those entities. And finally, the billing applications, yeah, likewise. Now, in since we have the, I mean, obviously, every system has a possibility of failures. So is the case with this insurance portal as well. So now let's say everything goes fine until the point we create a payment confirmation. So what happened, that user tried to attempt the home insurance portal, asked the user for the payment information, and it called the billing application, the service sections in the billing application to create the payment. And when the billing application tried to create the payment, there was an exception thrown, an error occurred. Yeah. Now, this is one of the possible exceptions that might happen in this entire sequence of activities. Um, then, so there are different possible situations. Then, so what will happen? So let's say The exception was thrown, and the home insurance portal gets to know about the exception in the payment action. So what it will do, it will invoke the cancel policy subscription action. So this is one of these way to handle the scenario of failure, right? So obviously, because the payment has failed, I need to cancel the policy in my claims application. Otherwise, the claims application would still believe that it has a valid policy for that customer, and then return the cancelled subscribe policy to the end user. Yeah, so obviously, when the policy subscription has failed, I have to intimate the user as well about the same. Now, this is, I mean, we just saw one way of handling that failure thing, right? Now, let's look at various compensation mechanism that could be possible. And these are just some of the use cases and the different approaches to handle those. I mean, these are not the last the final and the last thing to handle the scenarios, right? You can have your own situations and you can implement your own scenarios. This just gives an idea about how to handle those. So compensation mechanism that depends on the use case, like I mentioned. The final goal is to revert the state of the system to a consistent state. Yeah. So my system should be in a stable state. So for example, if we talk about the same situation where the payment has failed, I want to make sure that the claims info application is also aware that the policy is no longer valid or the policy is invalid, yeah, whatever. So I need to ensure that the claims application is also aware about that. And finally, the customer should also be aware about that his policy subscription has failed, right? So compensation mechanism, there could be various approaches, right? So rollback or soft delete of data. So we can roll back the transaction somehow, or we can simply soft delete the data, like we set those records as inactive or something. Yeah, and then we need to execute additional logic to ensure consistency. Like in this case, we inform the claims application and then we inform the end user about it. And also we need to ensure that while we are handling these failure scenarios, the any other transaction that is happening, right? So it we are also able to manage the concurrent transactions at the same time, because if the system is not in a stable state, then the concurrent transactions that are happening at the same time, they might read unstable data. So that is another thing we need to take care of. Now, so one of the compensation mechanism is the retry approach. So what we do, we sorry. So as soon as the operation is retried, immediate transaction recovery happens and no cancellation. So what we do, as soon as the exception is thrown, the home insurance application, what it will do, instead of simply invalidating the policy in the claims application and then returning the cancellation to customer, what it will do, it will retry the payment one more time or couple more times based on the configurations, right? So in that case, if any of those retries succeed, then we are in a good situation. Again, the system is in a stable state, and we can send a payment confirmation to the customer, right? So that is one situation. Now, retry also does not ensure that the recovery will happen, right? So, I mean, okay, I retried the payment, my payment might still fail, right? So in that case, again, I will have to inform the, I will have to invalidate the claims, the record in the policy in the claims application, and I will have to inform the customer, right? So now, how would you retry? So one of the possible ways to retry is to, let's say for one of the requests, the payment has failed. So what I will do, I will put it in a queue, and that queue will be taken care by a timer. So the timer will keep retrying the payment over and again, and for certain predefined number of times. And finally, if it reaches the maximum count, and if the payment has still not succeeded, then it will invalidate the policy in the claims application and then inform the customer. Yeah, so that is one way of retrying asynchronously. Yeah. So, like I said, I mean, these are some of the ways to achieve the apply compensation in the system in case of exceptional situations. But this is not limited to these strategies. You can come up with your own. There could be so many other situations, and you can have your own ways to handle it, agreed with the business. So these were just some sample scenarios we looked at, and that end brings us to the end of the presentation. If there are any questions, please feel free to ask.
Please make sure to write that in the Q&A section. That's the next thing we are going to do, question and answers. Any questions? Let's just wait for a minute.
So in case you have any questions, maybe later, then please feel free to reach out to me. Or if you want to discuss any topic in detail, please feel free to reach out to me on ADP list. I've shared my profile URL on the chat.
Yeah. So, as there are no questions, if you get any questions later, like Junaid said, you can reach out to him on EDP list. He's available on EDP list. So, mentor, he has shared the link. Great. So now I'm going to share my screen. I just have few things to share with you before starting the quiz. We'll have the quiz next, right? After Q&A, can you see my screen, guys?
Yes, Neha.
Yeah.
Yes.
Thank you. So, this masterclass, you can earn a voucher. We are done with two sessions already. So, because we came up vouchers just now, so for this masterclass only, we are going to give away vouchers on the basis of one single quiz. But like I said, we are going to have masterclasses every month, and we are going to give away vouchers every month. So if you want to earn those vouchers, you have to attend masterclass sessions, all the sessions, and those who are the top winners in all the three sessions. Normally, it will be three session masterclass. So all the three sessions who winner, they will get a specialization voucher. Remember, it's a specialization voucher. Last time, but when we got this drive for vouchers, people, they nominated themselves, they got the vouchers, but then they came up saying we have not completed the basic certificate. So that's why they were not able to use the specialization voucher. We are not going to guarantee that we cannot situation. Okay, so I request you here, we are going to provide only specialization vouchers. So it's a clear note that we are going to add, that these are specialization voucher. You can benefit from this only when you are having basic certificates. So make sure you have completed the basic one, associate reactive or associate ODC or traditional. I guess traditional does not count. So reactive or ODC. Okay, then only you can go ahead with the specialization voucher. Earning the voucher is very simple. Attend master classes, take the quiz, top the leaderboard, and win a voucher. Okay, that's the only thing I wanted to make sure that I have shared with you. Now, let me um, start with the quiz. Okay, I'll just share the quiz material. Stop sharing. Present the quiz. So it's a Slido quiz. I want all of you to take out your mobile phones, go to browsers, and search for Slido. I'm going to share my screen once it's going to share the QR code or number. Okay, can you see the QR code or the game number, game ID?
Yes, ma'am.
Thank you. So just enter your name and join. A nickname will also work, but just make sure you're entering and joining. Okay, 14 members have joined. Okay, 15 now. Guys, please participate. There are 23 participants, 21 I'm expecting. So please join quickly. We have 10 vouchers, right? When you are going to, like, only top 10 winners of this quiz will get the voucher, right? So please participate. 17 have joined, 18. Okay. Just one more minute, we are going to wait. If you are facing any difficulty in joining, please let me know, or otherwise, we'll be starting the quiz in a minute. Every question you will get 20 seconds to answer. Not only the correct answer, but who's going to answer fast, that also counts. So make sure you're marking the correct answer as soon as you spot it, right? Time matters. Okay, I'm going to start the quiz, guys. There are 18 participants. I want you to see this, the laptop, the computer screen, okay? You'll be seeing the question there, and please answer. Which patterns is best fits black box integration? You're getting 20 seconds to answer. 11 have answered, 13 have answered. Everyone, please answer. Okay, only 15 people have answered, and maximum vote is given to direct integration pattern. And others, there are 20%, so it's a mixed reaction. Let me reveal the answer. Answer is C, direct integration pattern. Most of you have answered it correct. I am going to show you the leaderboard now. Okay, so you are seeing leaderboard here for top 5, but I'm able to see top 10. Okay, maybe I'm not able to show you here. In my mobile screen, I'm able to see everyone, rank of everyone. Okay, at the end of the quiz, maybe I'll show you all the top 10 winners. Okay, let's go to the next question, guys. For which of the following pair, both the elements can be producer as well as consumer for each other? Okay, C got the highest vote, that is library to library. I'll just reveal the answer. Correct answer is C. Great. Let me reveal the leaderboard. Okay, we have, you can see the top 5 here: Rajshri, Sangam, Sana, Vajahat, Aditya. Okay, We have total 10 questions, guys, so all of you can try. I'm going to open the next question. I'm going to open the next question. Which of the following is an example of strong dependence? I guess this is the easy one. Please try to answer. Okay, 56 has voted for C, and all the other options got 11, 17, 17%. So it's a mixed reaction. C getting the highest. Let me reveal the answer. Answer is C. So most of you are correct. Let's go to the leaderboard. Okay, we have Sangam at the top, then Sana, Vajahat, Rajri, and Ramprasad. Okay, let's go to the next question. Which pattern is recommended when real-time sync is required? 15 have answered. Come on, everyone, please answer. Mixed answers it is. A got the highest vote, that is cold cache pattern. Transparency pattern, very little. Then direct integration pattern got 37. Distributed transaction pattern got 16. Let me reveal the answer. The answer is C. So, most of you have answered A, but that's not correct, guys. Real time sync is required in direct integration. Okay. Okay. Let me go to the next question. Which phase of architecture design process involves identification of bounded context? Identification of bounded context. When are we going to identify the bounded context? Again, it's a mixed reaction. Okay, 42% says assemble, that's the highest. Let me reveal the answer. Answer is B, organize. Okay, organize is the second step, right? So disclose is the first, then we are going to organize it, and then we are going to assemble. So organizing is where we start with bounded context. Let me reveal the leaderboard. Okay, we have Sana at the top, Rajshri, Sangam, Ram Prasad, and Vajahat. And let me tell you the next five. Sixth is Azim, seventh is Sachin, eighth is Sai Navya, ninth is Arshad, and 10th is Dinesh with Navneet at the 11th. Okay, so you all can come up, guys. Please try to answer. We go to the next question. One bug is reported on an application deployed in production. What is the possible way in ODC to fix it? Now, this is related to ODC, and I guess you might be knowing. Okay, maximum vote goes to last option, that is fix the bug in dev, then deploy the applications in QA as well as production. Let me reveal the answer. That's the correct answer. Most of you have answered correct. Great, we reveal the leaderboard. Okay, we have Sana at the top, then Ram Prasad, Rajshri, Vajahat, Azim, Sangam, Arshad, Sachin, Aditya, Sai Navya. Okay, next question. There are two applications, mobile and web. They have some CSS in common, and then they have their own specific CSS styling as well. Okay, I'm not sure if the question is from here. So, what will be the approach? That's the question, I guess. 43% says B. Create a library with base theme with common CSS. Create two more libraries, one having mobile specific styling, other web specific, and then both inherit from common base theme. Let's see the answer. Answer is B. Most of you are correct here. Now let me reveal the leaderboard. Okay, the leaderboard is pretty much similar. Sana, Ramprasad, Arshad on the third, Rajshri, Vajahat, Azim, Sangam, Aditya, Sai, and Sachin. Okay. Next question, the eighth question: how are user identities secured within ODC? Come on, guys, please try to answer. 16 answers registered. Okay. 72% says B, through a built-in identity service designed for user security. Let me reveal the answer. The correct answer is B. Most of you are correct. Let's go to the leaderboard. Slightly changed. We have Sana, Ram Prasad, Rajki, Arshad, and Sana. Let's go to the next question. I'll reveal the final leaderboard at the end. Okay. When deploying an app to production in ODC, what does the impact analysis feature do? Sixteen have answered. Guys, please answer. Okay. 79% says B. It analyzes potential dependency issues that might cause deployment problems. Let's see the answer. Answer is B. Most of you are correct. And the leaderboard looks like this. Okay, that's great. The leaderboard, the next 5% after Sangam is Sai, Navya, Vajahat, Dinesh, Sachin, and Aditya. Okay, we have the last question, guys. Now, please try to answer so that you are there in the top 10. Try to answer faster. Last question. Impact analysis stating that an app references a missing producer application. What does this scenario indicate? I got mixed reactions. 12% says A, 29% says B, and 53% says C. An application this app relies on is not available in the target stage. Let's see the answer. Answer is D. So most of you are correct. Now reveal the final leaderboard. We have Sana, Rajshri, Ram Prasad, Arshad, and Sai Navya. The next five are Dinesh, Vajahat, Sangam, Sachin, and Sashi. Okay. I'll be sharing the top 10. Okay, this result only. Let me see if I can show you all the 10 here. Let me close the quiz. Let me go back. Let's see if I can show you the top 10 at this moment only. Disconnected. Okay. So this was our quiz. If I go to interactions, if I go to leaderboard, yeah, this is the leaderboard. Can you see the leaderboard, guys? Everyone?
Yeah, I think so.
Yes.
Great, thank you. These are the top 10. Okay. So congratulations, all of you will be getting vouchers 10 vouchers we have, we'll be distributing to the top 10. Okay. Thank you so much for taking the quiz. I'm going to stop sharing. So we are done with most of the things. But I don't want you to leave. I want you to please start your cameras. I just want to take a quick picture of all of you have attended, and then maybe we can end today's session. Thank you so much, guys, for turning on your cameras. Everyone, I request you if you can turn on your cameras. Those who can, please turn on your cameras. I just want to take a quick picture. Thank you. I'm going to take picture now. Please turn on your camera. I am. It's like everyone is. It's just turning on and off, so I'm not able to take the picture. Please keep on your cameras. Great. I'm going to take the picture now. Okay. Yeah. Okay. That's done. Thank you so much for turning on the camera. And yeah, I'll be posting about this event on LinkedIn as well. So I request all of you, if wherever you get the voucher, you will get it soon. So please post about it and encourage others to join our sessions. Okay. That's it. That's it for today's session, guys. Thank you so much, Junaid, for
Thank you,
taking the
ma'am.
session. Yeah. Thank you, everyone, for joining.
Thank you.
See you in next session.
Bye.
Bye, everyone.
Thank you.